Hello everyone. Today I want to talk about the topic equals hypothesis, and because I know that there's a lot of students are confusing about this topic. Now, I know you learned it before, so look at the question and give a go, and then press play when you're ready. Okay, here you are. Look at the question here. The first of all here, you have to look at right in now here. You highlight the keyword first. Is 0.15, the chance of success, and we have the 30 customer. We collect the sample size and one customer who bought the item. Now to do this question here, keep an eye on 5% of significant level. That is to justify the answer. Now before I do here, H1 is stand for null hypothesis. That means the assumption is correct, and H1 equal alternative hypothesis. That means its assumption is wrong. Now, you know that the chance of success, you got 30 customer, which is your sample size. You know that X belong to binomial distribution is 0.15, and you see that highlight the keyword test whether or not. That means we don't know will be better than 0.15 or lower than 0.15. We don't know. Therefore, we have a different. That means you have a two tails test. So here you are. So mean each tail will be 2.5. Now the evidence which is one customer out of 30, and you know that the 0.15 is the chance of success. That means number expect to have 4.5 because 0.15 times 30 equals 4.5. So here only one customer. That means we know that it should be on the left hand side tail. Now we're going to find probability of X less than or equal than 1. That equal to 0.048. And how do I work it out? You should know using calculator. Is menu number 2, and then you should get out distribution, that is binomial, and you should code is CD. And you know that it's lower, which equals 0 because the lowest value, and up, which is the one we're looking for, which is 1, and the number trial, which is 30, and 0.41. That is the answer, which is 4.8%. Now you know that 4.8%, each tail is 2.5%. That means 4.8% bigger than 2.5% is, that means if the data is not within the critical region. So not within the critical region, we do not reject H0. That means we have to accept H0. And so what does it mean? It means here, if we accept H0, mean P is still 0.15. Okay, that means you say here there has no change in the proportion of customer buying an item from the display next to the till. So that could be the exact same as say not change because P is still 0.15. Okay, now part A, that's marked easily. Now look at part B here. When you read the question, you see that is during the refurbishment, the new sandwich, we talk about sandwich now, and you see that the customer bought is about 20%, that means 0.2. And you see that the shopkeeper claims that the proportion of customer buying sandwich now has increased. So you can see that is P now will be bigger than 0.2 now. So before you start, we're going to start here next one, carry on. Now he select a sample size, 120, quite big there, 120 customer. And you find out 31 of them bought a sandwich. But from this question here, you know that it increased. That means it has to be right tail, okay? And 10% level of significance, that is the keyword too. So we're going to do is, we're going to do the test again. We start from H0 first. H0 means the assumption is right. So mean P equals 0.2 first. And H1 means the shopkeeper claiming that it's bigger than 0.2. So therefore, we get bigger than 0.2 here. Now, after that, what X mean? The number of the customer. So X belong to binomial distribution, 120, which is sample size, and then 0.2. That is the chance of success. Now 31, that is the evidence. We need to work out what percentage of evidence here. 31. So inclusive, bigger than 31. But we know that is, we cannot work out normally using the formula booklet. So what we do, using suitable approximation. Now here you are. If we do that, then we have to change binomial to normal distribution. I call y now. Y belong normal distribution. In order normal distribution to work, we need the mean and variance. So here you are. What it mean equal to number of trial times by the chance of success, which is 120 times 0.2, we give me 24, and then NPQ, Q here is 1 take away 0.2, which is 0.8, so equal 19.2, that variance. So work it out is P. Now you know that we talk about is here, because from binomial to normal, we have to do correction value. See, 31 onward is the whole number. You have to go back outside the range by 0.5 unit. That means 30.5. So y have to be bigger than or equal 30.5. Now using calculator big one, so like Casio CG50, you can work out no problem there. You can do easily. So here you are, distribution. We're using normal distribution now, which equal is CD. And lower value we start from 30.5 because it starts from bigger than 30.5. We start from there. Upper will be gives you like about 1000, no problem there. And then is standard deviation, which is shift, and square root here, that equal to 19.2, and the mean equal to 24, and it got is 0.69 or 0.6898. So approximate 6.9%. It equal course is still less than 10%. So that is critical value. So 10% here, but 6.9%, that means within critical region now. I mean, if inside critical region, I can reject H0. I mean, accept H1. So therefore, there is evidence to support a shopkeeper. And one more thing here, sometimes people have a different calculator. They have a FX991 instead. Okay, so therefore, this technique here, it doesn't work. We have to convert them to the left hand side area. So we have to do is 1 take away P, which x less equal than 30.5. Now if you work this out using the FX991 and you take away from 1, you got exactly the same answer as well. And here you are, and we're done. Okay, here you are, that is question number 2, and I really want you to pause the screen and have a go. When you're ready, press play. Okay, here you are. But I explain what you understand by hypothesis. Well, this is more about is we test on parameter. The parameter could be is the chance of success, which is P, or could be the mean of normal distribution, and therefore we're using that, or is equal PMCC. That equal is a correlation. Correlation is quite simple. Well, just have a look at it. Very tiny bit. It's quite simple. Here you are. So it's more about population parameter. We test on that. So parameter basically that is I mentioned earlier. Now explain what you understand about critical region. I mentioned that question round 1 before. If you inside critical region, you are able to reject H0. Basically equal is the range value to reject H0 for her. Now you see that is we test on 5% of significance level, and opinion will provide evidence support Mrs. George claim. So before you do that, you know that it should be two-tail, because we don't know is which one is two-tail, and 20 times 0.45, the expected number is 9. Now 5%, we're going to start from H0, which is P, equal to 0.45, and H1, which P will be is different from 0.45, and because we test on 5% level of significance, that means 2.5% each tail. Now here you are. Now we expected the 9 voters because they're 20 times by 0.45, which is the expected value is 9, but now 5 we should be on the left hand side tail. So therefore, we're going to start from a 5 probability of, before you do that, X have to belong. X represent number of voter. So x belongs to binomial distribution, which equal 20, and the chance of success is 0.45. Now we're going to work out is phi x less equal than phi. You must have an inclusive sign in here, and should work it out from there. 5%. Now of course that is approximately 5.53%, which is bigger. That means it's not within 2.5%. So from there on I can say is outside the critical region. So therefore I do not reject H0. Then we have to accept it. Now from here you can make the complaint here. You can make the conclusion here. So therefore there is no evidence to support Mrs. George claim. Okay, now part A we've done. Okay, now part B now. From here, okay, first of all you see that we have using the table, which in the formula booklet we have using it. Now the same thing is P H0 P equals 0.45, keep the same. Now just copy down first so that you can see that what we is now left hand side tell. Here you are. They're saying is no one, to highlight the no one. That means the evidence is no one. So x equals 0. From 0 start from there. So we're looking for binomial at n, which we don't know, but that is 0.45. You look at the booklet here, binomial, to get about less than 1%. How to be less than 1%? So look at there for 1%. So you see that is. So that example here 1%. The color of the area has to be 1%. Okay, so how to be is between them. Okay, now I'm gonna look at the table first. Now when x equals 0 here and 0.45 here, that is 0.8%. So the value keep decreasing over time. At 20 equals 0, that means we have to go backward a little bit. So we'll flip on the table here. So you see that I got is 45 here, that's 0.5%. So increase slowly. So between it, that is 1.5% and that about 0.8%, between two values here at x equals 0. So we work out from there. So we write it down is at n equal 8, the value p at 0 equal to 0.0084, and at binomial at 7, 0.45 there, and you can see that is probability of 0 equal to 0.0152. Now you see that is to recheck. So the first to recheck is about 8, just less than 1% have to be in here. So therefore is n has to be equal to 8. Okay, everyone, that is number 3. So I want you to give up and pause the screen and have a go, and then click play when you're ready. Here you are. Number 3. State condition under which normal distribution may be used as approximation, we mentioned in the classroom. So the first thing is have to be is n is large. That is the 1 mark. It p has to be approximate equals 0.5. It could be 0.55, could be 0.56, 0.45, so on. Okay. Now part B, a company selling seed, okay, and claim it, so on. Now, the reason why company should not justify their claim by testing all the seed. So if they test all the seeds, there ain't no more seed, isn't it? So yeah, the saying is there will be no more seed. Okay, so we've done part B. Now we start from part C. To test a company claim that random sample size of 220 were planted. Stated hypothesis 2-tail. So they were mentioned 2-tail. So we start here 2-tail H0 P. Well, P equal to 0.55. Always equal here. And H1 is P actually different from 0.55 because it's saying it's 2-tail test. Now, they say to you is about 5%. Okay, done number here that the possibly done. Part D, quite simple. Right, so basically X belong to binomial. We should know that equal to 220, and the chance of success is 0.455. Sorry. Now we're gonna test on this one, but we don't know which left-hand side or right-hand side tail. So we know what I do is from binomial. I can work out straight there. So number expected. So we got 0.55. You multiply by 220 in total. That means 121. But you see that he correct 135. I mean it's more than expected number. That means it has to be right hand side. If it's less, it means left hand side. So it got its right hand side. So normally we would now if I probability of X will be bigger or equal than 135 because that right hand side tail. Now to work this out, and we have to do normal approximation. So we're using y value as the approximation. Belong to normal distribution, which you need to find the mean, which is NP, and an NPQ. Okay, so we know that normal distribution equal to 220 times by 0.55 give me 121, and an NPQ, which you times by 0.45 after that, and you should able to get the value is 54.45. That's variance. Now we're looking for probably X. Now you see it X start from 135 onward. I mean you have to get 0.5 unit outside the range. I mean X will be bigger equal than actually Y. Sorry, Y has to be bigger equal to 134.5 instead. Now, if you use normal calculator is CG50, I'm sure you can work out easily. But if not, you have using the calculator using the small one, which is FX991. You have to do equal to 1. Subtract the left hand side, which is left hand side area, which is less than equal to 134.5. Now, this will give you the answer. Now, the answer should be given is calculated out, and it should be equal to 0.0337. Okay, now that is 0.003, so that is approximate 3.37%. Now they're saying using 5% level of significance, that means will be each tail will be 2.5%. That means bigger than 2.5%, of course. That means outside critical region. If it's outside, mean it do not reject H0. So if you do not reject H0, then we have to accept it. Now, from here, we can make another conclusion here is if you accept H0, that means the company claim is justified. Okay, you make the conclusion is the company claim is justified. Okay, here you are, number 4. And you pause and have a go and press play when you're ready. Read question, make sure that is you highlighted sample size of n, and a normal distribution with mean equal 40 and standard deviation equal 3. Find minimum sample size, so probably greater than 42 is less than 5%. Now we're going to work out from there. So look here, that normal distribution like this, 35%, greater than 42, less than 5%. Okay, now before you do that is we carry on from here, mean equal 40 and standard deviation 3 square, which is 9, isn't it? Yeah. Now we need to do is about sample mean. Now because here the sample mean, highlight here, we greater 42. So we're looking for probably X bar, okay, it's bigger than 42. Now before you do anything here, you see that is because the sample mean, that is a normal value single item, so we have to find what is sample mean distribution is. Sample mean distribution is exactly the same normal distribution, the mean is still 40. But we talked about sample mean in that chapter already, which you have to divide, which is 9 divided by n. So variance divided by n, and will give me is, well, that is variance. So we're going to work out, from using that, we work out, because x bar here doesn't mean belong to the normal distribution of x. How do we belong to x bar? So therefore I'm going to find now. Now we don't know variance or standard deviation here, so therefore we must change it to the standard normal distribution with the mean equal 0 and variance equal 1. Okay, how do I change it? Exact same problem. Z bigger than 42 here. Take away the mean, which is 40, over square root of 9 over n. And of course, you work out from there is have to be bigger than now. 35%. 35%. So you see, we talk about area of 5%. So if that is value of z, that value of z here, in here, that is 5%. To be is less than 5%, that is z here. So 5% here. If we want to be less than 5%, the z here has to be bigger than that value here. Bigger than at 5%. I don't know what it is, but using table, try to work it out what is 5%, what value here equal to. And you see this one has to be bigger than that. So now we're going to work here from there. It's 2 over a square root of 9 over n. Now if you're using the formula booklet, at 5% you should have a 1.6449. Now you need to know that to get the value here is less than 5%, then of course the value here has to be in this side. That is 1.6449. The value here has to be on the right hand side of it, which means z has to be bigger than this one. Bigger than that one. Equal. Less we have to be bigger. So work it out from time cross. You got answer out is a calculator, which equal to 2 times here and then times, so n should be big equal to that is 6.087. Then I should have it the n equal to 7, and that is done. And to keep it highlight, the keyword here is from normal distribution and mean 40 sample mean. So keep an eye on sample mean. We have to convert the sample mean exactly the same normal distribution, but the variance divided by n. That is sample mean. Okay, everyone, it's number 5 now. Okay, last question. Alright, I want you to pause screen and have a go, and then press play when you're ready. Okay, here you are. We want to find the probability. We now show them. Okay, the weight powder here. Highlight the keyword first. That 1 kilogram, which is 1,000 gram of powder. X belongs to normal distribution. The mean equal mil, which we don't know. So therefore, X belongs to normal distribution. We don't know mil. So variance, of course, we don't know. We're looking for it. Now, so that is they saying is the probability of x less than mean, take away 30, had to be equal to 0.0005. Now, because we don't know the mean, we don't know variance, we have to convert them to standard normal distribution with the mean equal to 0 and variance equal 1. So we change it now to z. Have to be less than. So this whole value here, you take away the mean, which mean, mil, take that whole value here. You take away the mean over standard deviation. We should have a square here. Got that. That value equals 0.0005. Now, because we have to simplify it, now you can use in the to find inside the value of bracket here. What value here could it be? So it goes 0.0005. Now we can use in calculator to work it out. Sometimes we have to use the menu and matrix distribution. Now normal, of course, to find value inside the bracket, we have to inverse normal distribution. Here you are. And area, of course, the left hand side tail, we know that. And area equals 0.0005. And you got is standard deviation 1 and mean equal to 0 because it's that standard and equal to. So this value minus 30 over delta is equal to minus 3.291. Let's say that. Okay, you can do 0.5 and 267. Now to find delta here, so minus 30 divided by 3.2905267, and I should have the answer there. Now I try 30 divided by 3.2905267. Okay, I have answer is 9.117, and exactly I answered by 3 SF, 3 decimal places. So I'm done. That is part A. Now I'm going to do part B. Now you see that is the random, because that random sum of 10 packets is selected from the machine, the weight, the gram, each of them here, the first, second, there are 10 of them. That is the evidence. We have to find the hypothesis here. We're looking for the mean weight first. So there are 10 items, so mean weight. What do you do? Find mean weight. That's evidence we have to work out. Basically, you add 999.8 at every single until at 1002 here. Oh, you couldn't see it, sorry. And then you add 0.1. You divide everything by 10 because there are 10 items there. It should be give you is 9.54. Okay. Now that's the evidence. We're gonna justify that. Now we using 1% of significance level machine where the machine is less than 1 kilogram. So you say now we're gonna test 1%. So from there we're gonna using is H0 mean equal 1000, and of course H1 mean had to be less than 1000 because the question the test only reach here if the machine would delivering the package will mean less than 1 kilogram. So we test on the mean. Now first of all, you see that it equals sample mean now because that is 10 item, and we find the mean equals sample mean. And of course when you do that, you can find x bar equal to normal distribution, the mean equal 1000, and the variance we found earlier, which is that is standard deviation 9117. So 9.117 square over 10. That x bar, and we're looking for now is evidence is 999.54. So we know left hand side, so we're going to find probability of x bar less than 999.54, and using calculate work out straight away. You can see from here Alright, I is a 991FX or CG50 calculator. It should be exactly the same thing. Distribution, and you got normal, and then CD, and then you got it lower, which is you can put minus 1000 from there. Upper is 999.54, and then you got is standard deviation is square root of whole thing, which is 9.117 square over 10, and mean could give me is exactly is 1000, and I got is 43.66%, so 0.4466, so approximately about 44.66% compared to 1% significance level. That means way bigger than that. That means not within, outside the critical region. That means you do not reject H0, so we have accepted. So make the last conclusion is, so if it not rejected, the accept H1 mean the mean equal 1000. So make here is the machine is delivering packets with mean weight less, so not. So therefore the machine will not, so deliver not less than, so delivering packet with mean weight no less than 1000 gram. Okay, that is done, and that is answer number 5. And so if you have any question, please comment below the video, and also make sure to subscribe my channel so you won't miss any topic in the future as well. So here you are. I hope you revise well for exam.